Today's lesson is a polar coordinate system. First of all, let's find the relationship between variables. We use SOHCAHTOA. We know that y equals r times sine theta, and x equals r times cosine theta. And this r I can write down square root x squared plus y squared. And tangent theta equals y over x. We already learned the Cartesian coordinate system, in which each point is decided by x and y. Now we want to introduce another coordinate system called the polar coordinate system. Polar coordinate system is a two-dimensional coordinate system with the polar O and the polar axis L. Look at this diagram. And each point on the polar coordinate system is determined by the distance from reference point O and the angle from reference direction. In other words, any point P on the polar coordinate system is determined by this R and theta. Let's go to example 1. Plot these polar coordinate points on one graph. First of all, you need to figure out angle and then the distance from that reference points O. So pi over 3 is this line, pi over 3. Then we need 2, so basically it's here. Let's label this is A. Yeah, I label this is A. Second point, pi over 2 and negative 3. First of all, always look for the angle. So I will find pi over 2 is here. It's this line. But negative 3 is not this direction, will be opposite direction. So find the negative 3 here. It's 1, 2, 3. So it's here. This will be B. In other words, when this R is negative, it will be opposite direction. Now let's go to this C. Negative pi over 4. Negative pi over 4 will be this one here, this line. And then negative 2 means opposite direction. Therefore, I go here, opposite direction. That will be C. Now let's go to D. Pi and 1 over 2. So I will find the pi is this line. Then pi over 2 will be half of this. Let's go here. This will be D. Let's go to E. E is 4 pi over 3. 4 pi over 3 is this line. Then it's 1. Therefore, will be this point. It will be E. Now let's go to F. 3 pi over 2. 3 pi over 2, it's this line. Then R equals 0, it will be origin here, this one. So let's label this is F. Yeah, that's all these 6 points on the polar coordinate system. Now let's go to example 2. Identify the graph of each rectangular equation, then write the equation in polar form. Support your answer by graphing the polar form of the equation. Let's go to 27. X plus 5 squared plus y squared equals 25. We know that according to this rectangular equation, we know this is a circle. And we already graph this rectangular equation. How to write the equation in polar form? We need to substitute the x with r times cosine theta and y with r times sine theta. Therefore, we do r cosine theta plus 5 squared plus r squared sine squared theta equals 25. So we expand this binomial square. We got the r squared cosine squared theta plus 10 r cosine theta plus 25. Then plus r squared sine squared theta equals 25. So we simplify this 25 is gone. And r squared cosine squared theta plus r squared sine squared theta will got r squared, because sine squared theta plus cosine squared theta equals 1, and plus 10 r cosine theta equal to 0. We take r outside. Then we got the r plus 10 cosine theta equal to 0. This will be the polar form. Now let's look at another example. For y equals square root of 3x, we know this is a linear function. In Cartesian coordinate system, this will be the graph for y equals square root of 3x. Now we try to change it into polar form. Therefore, we plug r cosine theta for x and r sine theta for y. We got r sine theta equals square root of 3 r cosine theta. So both sides divided by r. We got sine theta equals square root of 3 cosine theta. Then we divided by cosine theta both sides. We got the tangent theta equals square root of 3. And this will be the polar form for this equation. Now let's go to example 3. Write each equation in rectangular form and then identify its graph. First of all, you have to know the following formulas. R will be square root of x squared plus y squared. And for sine theta, for cosine theta, and also for tangent theta. So for 32, r I change into x squared plus y squared equals 3 times sine theta equals y over square root x squared plus y squared. So both sides we multiply by square root x squared plus y squared. So this one we square that. And we got x squared plus y squared on the left side equals 3y. Therefore, we got the x squared plus y squared minus 3y equal to 0. We know it's a circle. So the rectangular form will be this one. Let's go to next example. Theta equals negative pi over 3. Now let's take tangent theta both sides. So we got tangent negative pi over 3 means negative square root of 3. And I change tangent theta into y over x equals negative square root of 3. So y equals negative square root of 3x. Therefore, we know this is a linear function. Now let's go to 34. We got x squared plus y squared. We do square root. We can get the 10. So we square both sides. We got the x squared plus y squared equals 100. And we know that this will be the circle. Here is the polar distance formula. If we want to figure out any distance between 2 points on the polar coordinate system, here is the formula. Basically, they use cosine law to figure out. Let's go to example 4. Find the distance between each pair of points. Remember, distance between 2 points on the polar coordinate system equals r1 squared plus r2 squared minus 2r1 times r2 cosine theta 2 minus theta 1. Remember, it doesn't matter we do theta 2 minus theta 1 or theta 1 minus theta 2, because for cosine, it's an even function. Therefore, for first question, d equals square root. We know that it's a 2 squared plus 5 squared minus 2 times 5 times 2 times cosine. 120 minus 30 will be 90 degrees. So we got square root of 4 plus 25. Cosine 90 equals 0. That means square root of 29 will be the solution to 38. Now let's go to 39. We still get the d equals square root 3 squared plus 8 squared minus 2 times 3 times 8 times cosine 4 pi over 3 minus pi over 2. So we got, this will be 9 plus 64 minus 48 cosine 5 pi over 6. Put this into the calculator, we got 10.7.